I'm Tanjun. I'm from DKM2A. My number is 09 DKM21F 1052. And today I'm going to talk about Engineering Math 2, Chapter 2, Differentiation. We have our team member. The first one is me, Tanjun, and we have SRIRAM, Nadaki, GANESAN. His number matrix is 09 DKM21F 1067. And other one is SHARVIN Another SASIDARAN. His number matrix is 09 DKM21F 1072. Okay, we're going to talking about topic of carpentry. So what is carpentry? Carpentry is a trade in which the majority of the work being done involves shaping, cutting, and installing various material as part of a construction project. Professionals use carpentry to build ships, houses, bridges, and concrete formwork. While this profession once focused mostly on working with wood, carpentry now involves working with various materials including engineering lumber, metal, and factory-produced elements. Tasks that may involve carpentry include installing, sealing, walls, staircases, and beams. What does a carpenter do? Carpenter also often have the following duties. The first one, create and reference blueprint throughout the project. The second, construct various framework for structures including walls, ceilings, and floor. The third one, they install fixtures as a cabinets, windows, and furniture systems, and they use machinery such as crane to perform duties. They can also cut and shape various materials. The duty is to ensure structures, framework, and material are up to code and undamaged. How is the rate of change used in carpentry? In carpentry, carpenters need to calculate the materials needed to have their work done. They will use rate of change of area and radius to find the best solution to finish a work. For example, the home framework need to be done, and they need to calculate how many wood planks or anything will be needed to use for the area for the frame, maybe framework, or maybe other than that. So they need to use rate of change so they can easy to done their work.
Hello everyone, my name is SHARVIN SASIDARAN. My matrix number is 09DKM21F1072. Today I would like to present about application of differentiation. First of all, what is the rate of change? The rate of change is the speed of change of a variable over a period of time. ROC, which is the rate of change, is often used when talking about momentum, and it can generally be expressed as the ratio between changes in one variable versus corresponding changes in another. Graphically, the rate of change is represented by the gradient of the line. There are some uses of differentiation in real life, such as like calculating the profit and loss in business using graph, checking the temperature variation, and to determine the speed or distance covered, such as miles per hour and also kilometer per hour. Application of rate of change. Rate of change can be expressed using differentials. If y is given to a function of x, then dy over dx is a rate of change of y with respect of x. If the rate of change increase, the value will be positive, while if the rate of change decrease, the value will be in negative. Chain rule is often used to solve problems on rate of change involving time is a variable. The formula of rate of change is dy over dt equals to dy over dx times with dx over dt. Now let's see one sample question of rate of change. The question is, the volume of a sphere is increasing at a constant rate of 12.8 pi centimeter cube per second. Find the radius of the sphere at the instant when the radius is increasing at a rate of 0.2 centimeter per second. The volume of sphere is given as V equals to 4/3 pi r cube. Okay, if you see that 12.8 pi, the unit is centimeter cube per second. So if you see the centimeter cube, it refers to volume, and the second is referred to time. So it is dV over dt is equals to 12.8 pi. Then they tell us to find the radius, and they already give the dr over dt, because they say the radius is increasing at the rate of 0.2. So we already get dv over dt and dr over dt. And now we can differentiate the v equals to 4/3 pi r cube. So we will get dv over dr is equals to 3 times with 4/3 pi r square, and we will get 4 pi r square. So now we already get dv over dt, dv over dr, and also dr over dt. Now we can use chain rule to find the radius. So I use dr over dt is equals to dr over dv times with dv over dt, and the dr over dt is 0.2. So 0.2 is equals to, the dr over dv is not given, but we already have the dv over dr. So now we can use 1 over 4 pi r square times with 12.8 pi, and 0.2 is equals to 12.8 pi divided by 4 pi r square. R square is equals to 12.8 pi divided by 4 pi times with 0.2, and r square is equals to 12.8 divided by 0.8, and the r square is equals to 16. So if we do the square root of 16, and we will get 4, then the radius is 4 centimeter. Now let's see another question of rate of change. The question is, a block of ice in the form of a cube with sides x centimeter melt at rate of 11.57 centimeter cube per minute. Find the rate of change of x when the x is 14 centimeter. In this question, they refer the side of the cube as x centimeter. Okay, the volume is x cube. So now we can differentiate the volume to get dv over dx. dv over dx is equals to 3x square. They say the block of ice is melting. It means the rate of change is decreasing. If the rate of change is decreasing, the value will be in negative. So dv over dt is equals to negative 11.57. Using chain rule, we can find the dx over dt. dx over dt is equals to dx over dv times with dv over dt. The dx over dv is not given, but we already have the dv over dx. So we can use 1 over 3x square times with negative 11.57. Now the x is already given, which is 14 centimeter. So we can replace the x with 14. So we will get negative 11.57 divided by 3 times with 14 square. And the final answer is negative 0.0197 centimeter per second.
Okay, my name is SRIRAM GANESAN. My metric number is 09 DKM2A 1067. Let's we go with the question. A sphere is filled with the air at the rate of pi centimeter cube per second. Find the rate of the radius when the radius is 3 centimeter. The given is pi centimeter cube per second. It's equals to dv per dt, and the radius is 3 centimeter. We should find the dr per dt. dr per dt is equals to dr per dv times dv. The v is consumed as volume. Volume's formula is 4/3 pi r cube. And when we differentiate it, dv per dt, it's equals to 4 pi r. Okay, then we got it, and we should do equals to 1 per 4 pi, r is equals to 3 and 3 square. Then times with pi, the answer is 1 per 36 cm per second.
We need to find the change of rate of the square whose side is 8 cm long if the side length is increasing at 2 cm per minute. So the first one, I'm going to take out all the data. So we know that the square is long of the side is 8 cm. Then it says the side length is increasing at 2 cm per minute. So it is the data for the dl dt. So we're going to need to find the rate of change of the square. So we're going to need use the formula dA per dt equals to dA per dl times dl per dt. So we know that the square area of the square is A equals to 2L times L. So it will be L square. Okay, so we're gonna differentiate it into dAdl. So it will be 2L dAdl for dAdl. So we know that the L is 8 cm. After that, we're going to move the take the xcm into the dA per dl to find its answer. So dAdl equals to 2 times 8, and the dAdl will become 16 cm. So we're going to need the formula done. Okay, just use the formula just now. dA per dl equals to dA per dl times dl per dt. So when 16 cm times 2 cm per minute will be 24 cm square per minute for the final answer. The surface of the sphere is increasing at a constant rate of 10 pi cm per cm cube, or constant rate of 10 pi cm cube per second. Find the rate of change of the volume. The radius is 10 cm. Given that A equals to 4 pi r square and V equals to 4 per 3 pi r cube. So we know that the dA dt is increasing at a constant rate of 10 pi cm square cm cube per second. So it is the data of the dA per dt, 10 cm cube a 10 cm square per second. So we're going to need to find the dV dt, and we're given that the radius is 10 cm. By given A equals to 4 pi r square and V equals to 4 per 3 pi r cube, we can use that formula to differentiate it and become dV dr equals to 4 pi r square for the volume, and dA per dr equals to 8 pi r for the area. So after that, we're going to find the dV dA. Because we haven't found the dV dA, so we're going to need the formula dV per dA equals to dV per dr times dr per dA. After that, we move the formula into the in the formula into the data. So the first one is dV dr equals to 4 pi times 10 square, and because of dr per dA is going to be 1 per 8 pi times 10. So the final answer for the dV per dA is 5 cm, I'm going to use the formula PV per dt equals to dV times dA, dV per dA times dA per dt for the rate of change of the volume. So we found that the dV per dA is 5 cm. So we're gonna times the 5 cm with the 10 pi cm square per second. So our final answer for the rate of change of the volume is 50 pi cm cube per second.
Okay, now let's go with the conclusion. Differential equations play a major role in applications of science and engineering. Its arises in wide variety of engineering applications, for example, electromagnetic theory, signal processing, computational fluid dynamics. These equations can be typically solved using either inertial or numerical. These equations can be typically solved using either inertial or numerical methods. Many of differential equations arising in real-life application cannot be solved analytically, or we can say that their analytical solution does not exist. For such type of problems, certain numerical methods exist in the review. Our main focus is to present an emerging meshless method based on the concept of neural networks for solving differential equations or boundary value problems of types ODE as well as PDEs. Different neural network methods based on multi-layer perceptron, radial basis functions, multi-quadratic function, and finite element, etc., are then presented for solving differential equations. It has been pointed out that the employment of neural network architecture adds many attractive features toward the problem compared to the other exciting methods in the collection of input data, robustness of methods, and the high accuracy of the solution made these methods highly acceptable. The main advantage of the proposed approach is that once the network is trained, it always evaluation of the solution at any desired number of points instantaneously with spending negligible computing time. Moreover, different hybrid approaches are also available, and the work is in progress to use better optimization algorithms. People are also working in the combination of neural networks to other exciting methods to propose a new method for construction of a better trail solution for all kind of boundary value problem. Such a collection could not be exhaustive. Indeed, we can hope to give only an indication of what is possible. Thank you. A vase with a circular cross-section is shown besides here. Water is flowing into the vase. When the depth of the water is h centimeter, the volume of the water V centimeter cube is given by V equals to 4 pi h times h plus 4. Water flow into the vase at a constant rate of 80 pi centimeter cube per second. Find the rate of change of the depth of the water in centimeter per second when h is equals to 6. V is equals to 4 pi h square plus 16 pi h. When we differentiate it, dV per dH is equals to 8 pi h plus 16 pi. When we apply the formula, dH per dt equals to dH per dV times dV per dt, it's equals to 1 per 8 pi h plus 2 times 80 pi. It's equals to 10 per h plus 2. When h is equals to 6, we just apply to this equals to 10 per 6 plus 4, it's equals to 10 per 8. When we change with decimal, is equals to 1.25 centimeter per second.
For the second Q&A question, the volume of a spherical balloon. The first question for the Q&A session, the volume of a spherical balloon of radius r cm is V cm cube, where V equals to 4 per 3 pi r cube. So you need to find dV per dr, and we just need to use the formula given, which is V equals to 4 per 3 pi r3. So how do we going to get this answer? So we take out the formula. V equals to 4 by 3 pi r cube. So we're gonna get it dy dx. So it will be dv per dr. So when we get dv per dr, the radius at the formula need to be -1 for the equation. So its answer will be dv per dr equals to 4 pi r square.
The last question of this Q&A section is, a radius of circular blot of oil is increasing at a rate of 2 cm per second. Find the rate of increase of the circumference. So the dr over dt is equals to 2 cm per second. The circumference, the formula of circumference is 2 pi r. So to find the dc over dr, we have to differentiate the 2 pi r and we will get 2 pi. And then in this question we have to find the rate of change of circumference, which is the dc over dt. To find the dc over dt, we have to use chain rule. So dc over dt is equals to dc over dr times with dr over dt. So the dc over dr is 2 pi and dr over dt is 2. So if we multiply this 2, we will get 4 pi. So the rate of increase of circumference is 4 pi centimeter per second. That's all from us. Thank you.